So now let's look at how we use an op-amp to create an inverting amplifier. If you recall, for the non-inverting amplifier, we connected the positive input terminal of the op-amp to the signal we wanted to amplify, and through a resistor we connected the negative input terminal to ground. In this case, we're basically going to flip-flop the two. So we'll draw our op-amp as we normally do, and we have a positive input terminal and an inverting input terminal, and we'll connect the positive or non-inverting terminal to ground. We'll connect the inverting terminal through a resistor to our input, V in, and we'll connect the output, V out, through negative feedback and a feedback resistor, RF, back to the negative input terminal. We'll call this resistor RI. Of course, we also have a positive input source and a negative input source. We can use golden rule number 1 to say that there's no current flowing into the op-amp through either of the input terminals. And we can use golden rule number 2 to say that the op-amp will adjust the value of V out, or VO in this case, such that the voltage at the inverting input terminal will be the same as the other one, which in this case is ground. So when that is the case, we see that we have, again, we can analyze this as we analyze a regular voltage divider. We have V out, which goes through a resistor of value RF to this node here. We'll call this node A, which, because of golden rule number 2, is equal to ground, which means that V is equal to 0 in this case. And then through another resistor of RI out to V in. So when this is the case, we know that the current going through resistor RF is the same as the current going through resistor RI, and we can write that the current through RF is just VO divided by the value of the resistor RF. That has to be equal to the current through RI, which is just minus V in over RI, because the voltage drop is 0 minus V in. We rearrange this algebraically, and we find that the ratio of voltage out to voltage in, which is just our gain G, is equal to minus RF over RI. So physically, what we see happening is that V in is let's assume it's some positive voltage, and because A is going to end up being, the voltage at A is going to end up being brought to ground, or brought to 0, that means that there's going to be some positive flow of current through RI in that direction. Because there's no current flowing into the negative terminal of the op-amp, that means that all of this current has to go through RF and eventually to the node here where the voltage out is. But the only way that's going to happen is if voltage out is negative, because we just said that the voltage at node A was equal to 0. So in order for the op-amp to maintain the same voltage at both of the input terminals, the non-inverting terminal and the inverting terminal, VO has to drop to some negative value, and that's where the negative part in the gain comes in.